disappeared in an array. Given an array nums of n integers where nums at the I index is, oh no, numbers of I is in the range, so that means every element is in the range 1 to n. So length is 8, so that means every element in this array will be from 1 to 8. Okay, so return an array of all the integers in that range 1 to n that do not appear in nums. Okay, here when we look at this XML, sorry. Okay, so how many elements in here? 8 elements, so it should be 1 to 8. So but some integers are duplicate, like 3 and 2 are duplicate, and then there is no 5 and 6, so we need to return 5 and 6. Okay, so we can do very simple way, right? For the very first time we can think, okay, we will just have from 1 to 8, right? 1 2 3 4 5 6 7 8, and then we will just check, hey, 1 is in this array or not. Hey, no, okay, yes, 2 is in this array or not, 3 is in this array or not, 5 though there is nothing, so we will take this 5 to our reset. We will take this 6 in our reset because there is no 6 in our input array. Okay, so let's do that way. For the very first solution way is like this, very similar way, very simple way, right? Okay, so I will create a new reset variable, and then I will just have the loop from 1 to where I'm gonna want on to 8, right? Length we start from 8. Okay, I plus plus, and then we will just check, hey, nums, hey, import array contain, do you have any values like I? No, we don't have that. At the time we will add to our reset, right? Because we are looking for the one who does not appear in that one. So just I will put I, right? And now we will return the reset. This is a very fast way we can solve this problem. Okay, so okay, let's think about the time complexity and memory complexity. So it is, so when we solve this problem, it is saying you may assume the returned list does not count as extra space. Okay, so it is saying, so we just use this one, but it is saying they will not count as extra space. It's okay, so we looped here, and then here contains, to check that this integer is in this array or not. It's gonna take order of n, right? So this is gonna be order of n square because we looped, we have another order of n in here, so now we loop here again, so it's gonna be order of n square. We don't need that, we want only order of n for the runtime complexity. So okay, let's forget about this way. Okay, what about the other ways we can solve in order of n? Okay, so I will create the reset array first. Okay, like this. So for now I will create the another way. Okay, 1 2 nums dot length for now 1 to 8, right? And then I will chain to our list. Okay, and then we have the list from 1 to 8, right? And then I will loop every integers in nums. Okay, and then we will add, right? And then we have reset array which has 1 to 8, right? But in this nums we will not have every integers, right? We will have some missing. So if we have here, we will have 1 to 8, but here we will not have others except 5 and 6, right? At the time we will remove everything from this nums. Okay, reset dot remove n from our integer, so we will remove everything. So when we see 4, okay, we will remove this one. 3, we will remove 2, we remove everything. But what we got as the result, what we left, so it will just leave 5 and 6, right? So we only had to return that result, right? Let's try this one again. Okay, I'm sorry, IE, oh I'm sorry, my typo. Okay, so what about what we think about what if we think about our complexity? So this is just one loop, right? So it's gonna be order of n, right? So but when we are creating this result, this is not an empty array, right? And then I think they will count as an extra space, because we need to create a list which will say from 1, 2 and dot length, right? So it's gonna be order of n for the memory space, so we don't need that one too. We don't want this one again, because memory, they want only order of 1, right? Like I mean, can you without extra space, right? So this is just an extra space because we create a list from 1 to and the length of the names array, right? So okay, we cannot do that way again. Okay, so how can we do the another way? For example, we will have this one. Okay, I'm gonna copy this one here. So we will have the index, right? Index 0, we will start from 0, right? 2, 4, 5, 6, 7. Okay, 7. So index 0 index. So in this 0 index, it should be 1, right? I know normally, I mean here 2, 3, 4, 5, 6, 7, 8. So okay, so this one is the index. Okay, this is index. This one is the no non-duplicates. Okay, and then this is the input. Okay, so here, so we will just think if index is 0 here, this is 1, right? It should be 1. If the index is 1, it should be 2. If the index is 7, it should be 8, right? So we will just think this one as a value. So 4 should be where? At the place of the index number 3, right? So okay, 4, this one should be in this place. So we will just think, hey, so for the first time, we will just look at very first element, 4. So 4 is index should be 3, right? So if the value is 4, the index should be 3. So we will look for that 3 index values, 0, 1, 2, 3, 7. Oh, I'm sorry. So here 7, right? So instead of this 7, we will just think, okay, 4 is already included. How can we mark this one is already included? I mean, when we see 4, we will just mark this one is 4 is included. Okay, so I will just multiply with -1. Okay, and then index, oh I'm sorry, this one is 3, right? So index is 3, so I will just multiply with -7. Here 4, I saw this one. Okay, and then when we see 3 is gonna be it should be index is 2, right, in this place. So okay, -3, I will just put every minus when I found some things. Okay, so here, so this is the original input array, right? So I will create this one is the original input array. Okay, so okay, and then 4 we will change this one -3, we will change this one minus. What about 2? So 2 should be in this place, right? So I will change this one minus. What about 7? 7 should be index number 6, right? Minus, and then 8, I will change this one. 8 should be at the index number 7, right? I will change this one minus. And then what about 2? What about 2? 2 should be in the index number minus, so we already put that minus, so we just put that minus 1 and 2, right? Again, right? So just minus, and then we can do this one as an absolute value, and then we will multiply with the minus 1 again. Okay, so okay, this is already minus, so just leave that. And then this one, okay, this is already 3 should be in index number 2, right? It is already minus. So what about 1? 1 is at the 0 index. We'll just put this one. Okay, so now we left this place. This place is what? 0, 1, 2, 3, 4, and 5. 4 and 5. This one are positive, so we will just get that one. Okay, this one is positive, so we will just add 1 to the index. So 4 plus 1, we got 5. 5 plus 1, we got 6. So we will get 5 and 6 as a result. Okay, so we will change the integers by using their index, minus 1, minus 1, minus 1, and then we will leave minus a positive integer in the missing index, right? So we will just return by adding plus 1 index, right? Okay, plus 1 to their index. So we got 5 and 6. Okay, I'm not sure if I explain clearly, but let's try to look at the codes, and then I think it will make it clear. Okay, so the same way I will create the new list. This is just an empty, so they will not count, right? So I will loop every integers in the input names, and then I will just get the index, right? So this one index this one is the index from 1, right? So here I'm sorry. So how can we know this one is 4? 4 means we need to get 3, right? So okay, so max dot, because sometimes it can get the minus values, right? And then n for minus 1. So we got its original index, right? 4. So 3 should be in this place, right? So we got 3, right? And then we will change that values with the minus 1, right? So because I don't want to use the extra memory, that's why we will we will play the integers only in the input array. So we are not creating this one as a new array. Okay, so I will just play the integer values by multiplying minus 1 only in that input arrays, right? So we will not have the extra space. Okay, so numbers index, so we got 3, 0, 1, 2, 3. Okay, this one is gonna be minus 1 multiplying, right? We will multiply that one. So if it is already minus 1, we will just it's already be the minus 1, it will be the same as a minus 1. Every time we found that place gonna be minus 1. Okay, so by doing that way, we will get this array, right? Okay, so and then we will loop that again. I equals 0, and then I less than nums dot length, and then I plus plus, right? Because we will check this one, right? So if nums I is greater than 0, that means this one missing 1, right? At that time we will add to our result index. Now index 4 and 5 are greater than the the integers at the index number 4 and 5 are greater than 0, right? So at the time we need to plus 1 to their index, right? So I plus 1, okay? And then I will return my reset, ISULT reset. So it's gonna be order of 2n, right? But it's okay, order of n. Oh, I'm sorry, what's going on? Order of 1, 5, 6, 7. I think I need to, oh, I'm sorry, not n, right? Numbers at the I index is original values, right? Okay. So it's gonna be order of n, and then we don't need the extra space. This is just an empty variable to return, right? So I'm gonna submit this one to see what will happen. Okay, I'm not sure what will happen. Let me try this one too. But it is asking not to use the extra memory, so this is using the extra memory, right? Okay, so we see the difference, right? The time difference. Okay, so this way is the better way among those three solutions. Okay, is the best one here. Okay, I'm sorry. Okay, so that's it. To see the time difference. Okay, so cool. That's it. Thank you.